Let's see. Okay, so let's get going. Sorry about being late. It was a morning of confusion for me. So today we're going to be talking about milestone 2 some more. How many people started on milestone 2? Okay, so most of you. So great. Okay. So we're going to talk about, well, first thing we're going to talk about is where we left off 2 weeks ago. We had figured out how to project our map correctly into an XY coordinate system so it didn't look distorted, and we could draw it. And this is what the code looked like. So we had this global variable, intersections, and in it we were storing a lat long position of every single intersection. And in our redraw function, so this draw main canvas was redrawing over and over again as we pan, zoom, move around. And we're converting from longitude to an X coordinate and from latitude to a Y coordinate. And then we're drawing a rectangle, a filled in rectangle of size 100 meters by 100 meters where that intersection is. Okay, and that looked pretty good. It wasn't distorted, looked nice. Okay, this routine is speed critical. It's the most speed critical routine by far in milestone 2. Actually, nothing else in milestone 2 is speed critical. It's all this routine and any helper functions that it calls. Because you're trying to make your map feel interactive. Redraw speed is what makes it feel interactive. Okay, so is there anything, well, before I show you the answer, is there anything you can look at here? There's not much code in this redraw function right now. Can I make it faster? Does any of this look wasteful? Where I could do it a bit better? So why don't you think about it for a second? Tell me if there's anything in here you think you could do it a faster way. Remember, you still have load map. You can store anything you want in load map. Right now in load map, we load up this data, but we can load anything we want there. Okay? So that's a big hint. Can you think of anything we can do to make this faster? While you think about that, I was going to make sure that the Zoom meeting, which is recording this, is working. Looks like it is. Okay. So any thoughts at all? So all this look completely necessary, or do you think you can move? You can't just get rid of some of it, but you can move some of it to load map. So what do you think? Any ideas on what you could move into load map to make this faster? So you're looking for computations that are kind of done over and over again in your redraw. And instead, could you move into load map and just do them once per map? You know, maybe once for your whole program if you only load one map. If you're able to load different maps in your program, okay, it's still only going to be once per load, which is not very often. So what do you think? What do you think? Yeah, so I'm just going to repeat that for people on the line here. So the suggestion is, why don't we store these X and Y? We're going to call this, so this redraw gets called a lot. If you click on, you start dragging your graphics around, it's redrawing many times. As you're zooming in and out, every one of those is a redraw. So we've got a loop here, and inside that loop, we're computing this X and Y for every single intersection, and we're doing that for every single redraw. Does this X and Y change for a given intersection in a certain city? The answer is no, it doesn't. You don't see anything in here that's a function of what the user did, nothing, okay? So this is not changing. So we can pre-compute it. So you can say, okay, well, is it worth the effort, right? Anytime I go to rewrite some code, you should ask, is this really worth my effort? So this is what we're doing over and over again, this X from lon and Y from lat. And I pasted in the code for X from lon. So X from lon takes in a longitude, and it does 1 multiply, 2 multiplies, 3 multiplies, 4 multiplies, and a cosine call. Okay, now if we're doing one of these, who cares? But we are doing this one per intersection. It's about 150,000 intersections. Then we also do some stuff for latitude. Seems like it might make a noticeable difference. So let me ask a quick question here. Okay, so I'm going to go out here. So here's the skill testing question. Okay, what do you think is more expensive, the multipliers or the cosines? Any thoughts? What takes a computer longer? Okay, so I'm going to give you a skill testing question. Going over to this table, we're going to do a competition between this table and your table over there. Okay, so here, I'm going to give you each a question. We're going to see how this goes. Your question, you can confer on this if you want. What is 2 times 2? 4. Very fast. Okay, now your question. What is the cosine of 2? Oh, they killed you. So, I mean, if you're still thinking about it, they just spat it out. Cosine is harder, okay? Not a fair question. For a computer, cosine is also harder. Multiply is a built-in instruction. One instruction takes usually, we can have it issue one every single cycle. Cosine is going to be some Taylor series expansion or some complicated subroutine. It's going to take a lot longer. Okay, so this cosine is actually more expensive than all 4 multiplies. And it's actually the #1 thing you're trying to get rid of. But if I'm going to get rid, I could store, therefore I could store this answer. That would actually be good. That's storing one number in load map. It's going to speed up my map if I do that. I'm going to go even further. Why not just store all of this? Okay, so I'm just going to store the X's and the Y's, which is what was suggested. Okay, so yeah, we want these redraws to be really fast. Ideally, we get them down to 10 milliseconds is fantastic. If you get this down to 10 or 20 milliseconds, it's going to feel very smooth. Get it down to 100, it's going to feel pretty smooth. If you don't get it to that level, it's not the end of the world, but it would be nice to make it really smooth. Okay, so you guys already gave me the answer. We can pre-compute this. Instead of storing the latitude and longitude for every intersection, it's actually no more difficult for me to just store the XY location. And I'm going to store that in an actual point2D. So EasyGL defines this very simple class called point2D. It's just an X and a Y that are grouped together. I'm going to pre-compute that for every single intersection. So I've got my intersection data structure, and I've got a global variable called intersections. So I'm going to have one piece of information for every single intersection. And instead of storing the latitude and longitude, I'm now going to store the XY. And all I have to do that is basically move this bit of code into my load map. So it's not very difficult to do. And once I've done that, my draw main canvas, my redraw function looks simpler. Okay, so I just go through every single intersection. It's right there. And I say, draw a filled in rectangle. Lower left point is the value that I've pre-computed. XY I've already figured out. And a fill rectangle actually has a few different ways you could call it. I can actually call it with just a lower left corner and a width and a height. So I'll call it that way. And okay, so let me quickly bring that up and demo it to show you that it does indeed work. Okay, and here we go. Okay, so this is just the code that this is the changed code from 2 weeks ago, changed to the way that I just showed you. And yeah, it works. Okay, so just to remember what it looks like, we can zoom in, we see all these intersections, we can zoom out. So it works fine. I've actually inserted a little bit of timing code. So let me go back up and show you this. Whoops. Okay, this page up doesn't work, I guess. Okay, so what have I done? So I made a global variable. Okay, this intersection data. It's got a point2D and a name, like I told you. It's also got one more variable that we'll use later. Okay, so I've got one of those for every single intersection. I've got my little helper functions. Okay, and let's go down here. So in my draw map function, you remember this? I basically, I'm going to compute my minimum and maximum longitude, and I've now moved that into a helper function. Okay, so I've got this little, go up here. I've got this little helper function. Let me shrink this down a little bit. Let's see. See if I can shrink this. There it is. Okay, so I've got a little helper function that you saw most of this 2 weeks ago, computes minimum and maximum latitudes and longitudes. And now it also stores the X, Ys. Okay, so it just has these 2 lines that store my X and Ys. And it stores a little bit of other stuff that we'll talk about later. So if I go down here, this is my draw map function. So it calls that helper function, sets up my window, sets up the initial coordinate system, and calls application run, which hands control over to EasyGL. In my redraw routine, it basically looks like what I just showed you, right? It's running through all the intersections and drawing them, and there's not much code left in the redraw because I've pre-computed these X, Ys, so it's faster. I wanted to see how fast this was, so I took the code that I presented in lecture on Chrono and basically put it inside my redraw routine. So I'm basically timing the whole redraw routine and printing it out. Okay, so let's rebuild this again. So I'll stop running this. And let's see. All right, so let's see if I can find this and stop it. Okay, so make sure it's built, run it again. Okay, you can see it's now printing out some times. Whoops. So as I zoom in, it's going to tell me how long everything takes. Make that a little bit bigger. Okay, so let's say I click zoom in. You'll see a new line comes out. It's pretty fast. That took me 0.04 seconds to redraw. If I zoom in, zoom out again, 0.006 seconds. As I zoom in a bunch, it actually gets faster. So it's now down to about 0.12, and that's kind of the lower bound. That's where it stays. So it's pretty easy to time your redraw function. If you have helper functions in your redraw function, it's pretty easy to time them. So you can see where your time goes and whether you're making things faster or slower. You can also tell, do you meet your goals that you lay out in written document 1? You should have a test plan in there. So do you meet it or not? Why do you think this gets faster as I zoom in? Let me do a zoom fit. So that takes 0.006 seconds. I'm going to zoom in a bit. It keeps getting faster. Eventually, it kind of hits a lower bound at 0.12. Why do you think it gets faster as I zoom in? Yeah. Yeah, it's less to draw. So I didn't actually, you notice that I've still drawn all the intersections. I didn't put anything in my redraw function that's very clever. EasyGL gets faster. Okay, things that are off screen, it figures out pretty quickly and it returns. So that fill rect gets faster if there's not actually many things that are on screen. So you'll get some natural speed up as you zoom in if you don't do anything. Okay, so let me go back to the slides here. So I went and timed the code from 2 weeks ago as well, which didn't convert to X and Y in advance. It just did it in the redraw function. And this does make things faster, okay? When the whole map was displayed in the times that I ran, in the time test that I ran, basically this changed to pre-compute X and Y, sped things up by 1.5x. When I'm zoomed in, it sped it up by a bit more, 2.1x. The reason I got a bigger speed up when I'm zoomed in is basically fill rect is getting faster. So as the drawing calls get faster, everything else becomes kind of relatively more important. Okay, these redraws are all pretty fast. So the truth is, if you didn't have to do, if this is it, like these are the speeds that you got all the time, and there was no more drawing, then you could just say, who cares, right? It's already fast enough, nobody can tell, because these are down in the 3 milliseconds range, which is fantastic. But you're going to find that when you draw streets and so on, it slows down more. So these tricks can actually help you with there as well and be noticeable. The number one thing to get rid of is that cosine of the average latitude. That's like one number. And if you store that number, instead of recomputing it millions of times as you draw streets and so on, you're going to speed up your map by a noticeable amount. Okay, and it's pretty easy. Okay, so hopefully that was all clear. Basically, do what you can in load map, as long as it doesn't make your code too long or take you too much effort. Okay, next thing I want to do is react to mouse clicks. So when we've been using application.run so far, right, where we hand controlled the EasyGL, in those examples 2 weeks ago and the first one I showed there, we had 4 null pointers. Now I'm going to change one of those null pointers to the name of an actual function that I wrote. And I named that function act on mouse click. So basically, these are 4 callback functions. Functions you can pass in, the names of functions, which EasyGL will call when certain things happen. So we started off by just passing null for everything. So we're saying, we don't want you to do anything when things happen except redraw the screen. The redrawing screen callback we always have to have. But the other ones we didn't do. Now we're going to send in a new callback. And the second callback is what should happen when the user clicks on the mouse. Okay, when the user clicks on the mouse in the graphics area, the part where you're drawing. The user clicks somewhere else, EasyGL already knows what to do. It knows how to make the buttons and so on. This is when they click on your map. Okay, so we got to write this function. The name of the function has to match the name we put here. Okay, so we registered a callback, we have to write that callback. The callback signature must match what EasyGL expects. And for the mouse click callback, it expects to get a pointer to the application. It expects to get this data structure which is basically information about the event. So we can use that to check which mouse button was clicked and so on. And you can look in the EasyGL example program or its documentation to see how to do that. And the XY location where the person clicked. Okay. So right now we're not going to pay any attention to this. We're just going to say we don't care which button they clicked. No matter what button they clicked, we're just going to do the same thing. So we'll ignore that. But we are going to pay attention to where they click the mouse, the X and Y. Okay, so this X and Y is going to be in world coordinates. So it's in the coordinate system that you chose, which if you use the code that we were talking about 2 weeks ago is going to be meters on the Earth. So this XY will be passed to us. I'm going to print it out right away. And then I want to print out what is the name of the closest intersection. How would I find what intersection is closest to this click? What should I do? Any ideas? Yeah, what do you think? Yeah, so great answer. So in milestone 1, you actually wrote a function that if you had a lat long will tell you what is the closest intersection. This isn't lat long, but we can write helper functions to convert from XY to lat long, right? It's just the opposite of what we did from lat long to X and Y. And then we could call the function you already wrote and test it, and you get the closest intersection. Graphics packages, pretty much any modern graphics package cannot tell you what you clicked on. Okay, it can tell you where you clicked, and it's your problem to figure out what that means. Does that make sense? So some of the students are like, well, can't EasyGL tell me what intersections there? It doesn't understand your intersections. It has no idea what you're drawing. It just calls a callback. So when you get a mouse click, it's up to you to decide what does that mean. Okay, so yeah, basically we could rewrite looping through all the intersections, seeing which one is the closest. That's basically what we're doing. But you already wrote that in milestone 1, so we're going to use that. But because it takes a lat long, we first have to convert. So I'm not going to show them here, but I can write a couple of helper functions that go from XY to latitude and longitude. And then I can call my M1 function and get the answer. Okay, does it make sense? Everybody with me so far? Does this make sense to you? Okay, sounds good. Okay, so that's how, when the end user clicks somewhere, we can figure out what they clicked on. For intersections, we're going to say, what's the closest intersection to that location? Now, for milestone 2, you're supposed to highlight this and print out some information. How are we going to highlight this? So how will we make this intersection a highlight? So let's say I've decided I want to draw it in red. I'm currently drawing all the intersections in black. I now want to draw whatever you clicked on in red. How am I going to do that? So any ideas? Somebody's got to have an idea. What do you think? Use set color. Yeah, so we are going to use set color. And then where do you want to draw it? Sorry, I can't hear you. Can you say it a little bit louder?
Wherever the mouse is clicked.
Wherever the mouse is clicked. Okay, so, and basically I think you're saying draw it in here. Like in this function, when the mouse is clicked, put a draw and call in there. Is that right? So we could do that. How many times will that draw it? So if I do that, you highlight, you click on an intersection. It's highlighted because you draw, you're basically saying do a set color call. Here, let me put this down so you get. Saying right here, do a set color call, and then do a fill rect call, right coordinates, and the set color is going to be red, and it's going to, yeah, we're going to wind up drawing that intersection. So that will kind of work, but there's a problem with it. Does anybody see what the problem is? So how long will this stay highlighted for? Yeah, what do you think? Yeah, so this will stay highlighted until the next redraw. And redraws are very frequent. If you put another window in front of that one, you get a redraw. Like, well, you put a window in front, then you bring this one back to the front, you get a redraw. You minimize it and bring it up, you get a redraw. You drag your view, you get a redraw. You zoom in, you zoom out, redraws. And this is, so you're going to get this drawn once, and then it's going to disappear as soon as the user does something else. Like, does that seem correct to you? What do you think? Do you see programs that do this? Like if you, in Google Maps, for example, if you click on something to highlight it and then you resize the window, does it go away? No. So some students will wind up doing this, and some will argue passionately with their TA that it was a user interface choice, but it's not really a rational user interface choice. Nobody goes, yeah, like I want you to show me something, but if I move the window, make it disappear forever. So you can't argue, you can try. You're unlikely to win that argument with your TA that this is a good user interface choice. So just drawing it in the mouse call black is not quite correct, okay? So where should we draw it? Gotta draw it somewhere. How are we gonna make this work? But what we want is if we highlight this in red, we want it to stay red, okay? Like we don't want, if the person zooms in to see more about that it suddenly stops being red, which is what would happen if we put the drawing call inside the mouse call black. So what are we gonna do? How do we make it so that it's gonna redraw as red either forever or until we decide to clear it? You know, maybe we give them a clear button, or maybe when they click on the next intersection, we de-highlight this one. What do you think? Yeah, so in draw main canvas, our main redrawing routine needs to know that this should be highlighted. It should be drawn in red, okay? So how are we gonna tell it that? So we need what's called stateful graphics. This mouse routine, this act on mouse press, has to store some information. Where do you think it's going to store that information? It's going to store it in a local variable, or is it going to store it in a global variable? They're the two basic choices, okay? So what do you think? If we store it in a local variable, is our redraw function going to be able to see what we did? No. So it's going to have to be a global variable, right? We can put it in a structure with some other variables, our other global variables, to try to keep things clean, but it's got to be in a variable that stays alive after we leave this routine, okay? So that our redraw function can see it. Does that make sense? Okay, so this is called stateful graphics. So how do we do this? Well, we already saw some of it. We have to register our callback function, and I already showed you that code, right? That was here, an application.run We passed in the name of the callback function. That's registering the callback. It says, what do you do when there's a mouse button click? Okay, so we already did step one. Then step two, we have to actually write that callback function, right? It has to find the intersection closest to the click. We talked about, could we draw it? We could, but that's not really going to work properly because it won't be persistent, it won't stay highlighted. So we want to record that it's highlighted, and we have to record that in a global variable. And then we have to modify our screen redraw function to highlight it, to look at this global variable that says, are you highlighted or not? Does that make sense? Okay, so register the callback. Looks like this. I already showed you the code. Act on mouse click is just passed into it. Nothing special about that name. It's just whatever name I give it here, that's the routine I better write. The general form of this application.run, the function call that hands control to EasyGL, is it actually takes 4 callbacks. Act on mouse click is the one we're using now. There's another one that you can use to do some more initial setup. It'll only be called once. It gets called basically when EasyGL is setting things up to let you do some of your own work. There's one that you can set where it will be called every time the mouse moves in the graphics area. So you can use that if you want to do, for example, show some information when people just hover over things. And there's one that will be called whenever the person hits the keyboard. So hit a keyboard key, you'll be told about it if they do it over your graphics area. So any one of these, you can just say, I don't want to do it, and pass a null pointer. If you want to take some action for some of those other events, then you pass in a callback. And where is this done? It's done when you're setting up your graphics window, which is in your draw map function. So you just do this once. You register the callbacks. Everybody with me so far? Let me check the chat. Looks like there might be a question in the chat. Yeah, and yeah, so Mohammed is right. So he said store the color in the intersection data. So this is exactly right, Mohammed, about how do we do the stateful graphics. Okay, so we have to write the callback function. We already did some of that. So here, I'm just repeating it. We're converting to lat long, finding the closest intersection. Okay, and then we have to store the callback function. Can't just, right now it's printing out where did the person click, printing out what is the closest intersection. And we need to do more than that. In order to actually highlight it in the graphics, we're going to add this Boolean highlight value, and we're going to add it for every single intersection. Okay, this is our interdata structure. And we've got a global variable called intersections already with one entry in the vector for every single intersection. So we're going to, for the intersection that you just clicked on, we just figured out this ID. We're going to set the highlight variable for that intersection to true. And now it'll be highlighted. Does that make sense? So I've written a knit false here. So basically, we should make sure that highlight is set to false for all the intersections, because I want to just have them all draw black until people start clicking on them. Now, I could do that this way. You can actually write this in C++. I can say equals false. And that basically means when this object is constructed, that this should default to false. Is that good enough? That's a common thing people will do. It's good enough if you only load one map, but it's not a great practice because if you ever load a second map, you're going to want, or you ever open the graphics more than once, the second time this initialization doesn't happen because this initialization only happens when this global variable is constructed, which only happens once at the start of the program. So I just made a note to initialize this to false because the right place to initialize to false is in load map. Now, every time I load a new map, I'm guaranteed all the intersections are not highlighted. If I instead did it, in a constructor or with a statement like that, which is basically like another way of writing a constructor, it's not quite right, and this will be a common thing that students will go, well, the first map works fine, and then the second ones behave oddly. Because that's usually because they're trying to do some of their global variable setup in the constructor or with defaults like this, and you shouldn't do that. Do it all in load map. Okay, so I just made a note to myself that it should be initialized to false. So this makes sense to everybody. So you can see what we're doing here. So just figured out which intersection it is, and then we recorded it in this highlight value. We have a highlight value for every single intersection. So we just turn it on for the one you clicked on. Okay, the last thing we need is to draw the state. Okay, so here is our draw main canvas. It's just a little different than what we had before. So it goes through all the intersections just like it did before, and it gets the XY location of the lower left or of the intersection, and it draws a rectangle of 100 meters wide, 100 meters high. But we used to just always set it to black. So we colored everything black, and now we've got this if statement. So if this particular intersection is highlighted, we set it to red, otherwise we set it to black. What do you think? Does this code look good to you? Is everybody with me? I need some feedback. You guys are used to being online. You're like, I'm just clicking the mouse, I'm grabbing a coffee. So, okay, I see some people putting up their thumbs, so yeah, it looks good. Okay, so let's demo this. Let's see if it works. Let's see. Okay. And just because it's a pain to write all this stuff in a real rush, I have already written this at the bottom. Okay, so I'm going to turn off this draw map and turn on a new version that basically has that highlighting code. But otherwise, it's basically just what you saw in the slides. Okay, so I'm going to build that. I'm going to run it. Okay, so I'm going to zoom in a few times here so I can see things better. And okay, so I'm going to click on this intersection, and it should turn red. Okay, so I just clicked on it. Didn't turn red. Why did it not turn red? Any ideas? Okay, let me give you a hint. Okay, I'm going to zoom in. Actually, I'm just going to move over a little. Now it's red. Okay, I'm going to click on another one. So see where my mouse is. I'm going to click on that one. Didn't turn red, but I'm going to zoom in one. Now it's red. Okay, and now I'm going to move it around a bit. And it stays red. Okay, so it's staying red. That's good. Okay, I don't have this awkward argument that I can't win with my TA. Well, my highlighting goes away. But let me do one more time here. So I click on this one. Still didn't turn red. But if I zoom in, it turned red. So what's going on? What do you think? Right. So yeah, exactly. So I'm getting the highlight set correctly. As soon as the next redraw happens, it's correct. It'll be correct forever after that. But the redraw doesn't happen right away. So it's kind of awkward. You click on it, and then only if you trigger a redraw somehow will it turn red, which is very confusing to an end user. So we'd rather not have this. This is another common argument with TAs. We argue, oh, that's my desired user interface. Again, this is not logical, right? So you just not gonna win that argument either. So let's see, what are we gonna do? This one's actually not very hard to fix, but again, it's a common bug. So go and check this. So we could write some drawing code in our mouse function. Okay, so we put the drawing code back that we had before. That'll work because now we draw it right in our mouse redraw function, and we draw it in our screen redraw function. It'll be fine. But it can be a pain to go and duplicate some of your drawing code inside your, mouse callback function and try to keep it up to date. So it's usually more convenient to just tell EasyGL, I want you to trigger a redraw, which is what this refresh drawing does. So it's going to be pretty common that in your mouse or possibly keyboard callbacks that you'd say, trigger a redraw, because now I've updated some state and I want you to make sure the screen's up to date. And that's really easy to do. That's why we pass this application pointer, or part of the reason why we pass this application pointer into your mouse callback, because you can use it to make calls into EasyGL like refresh drawing. Okay, so you want to memorize that one, you're likely to use that. Does that make sense? So that's going to get rid of this annoying behavior where it doesn't redraw right away. The other thing I'm showing you here is in the previous version, and I'll run it again in a moment, we didn't show anything in the graphics. We basically printed some information to the terminal, which isn't terrible, but it's maybe not the most user-friendly. And it's not that hard to put some information in the graphics. So the UI that we've set up by default for you, the default EasyGL setup, has what's called a status bar at the bottom. And the status bar is just where you can write a message. So what I've done here is I'm basically using standard C++. Did you guys use string stream in 244? Does this ring a bell? Okay, if you don't like it, you could also use sprintf, which is the C version, the C way to do this. That'll work fine too. It's like printf to a string. But basically what I've done is I'm just making, I want to make a string. And I did that by saying, print to the string stream, intersection selected, and then the name of the intersection. And you can get the string out of a string stream with this function call. You say .str, okay? So you go to c++.com, you look at string stream, it'll tell you that's how you get the string out of it. So I'm basically getting the string that I've created with string stream, and I'm passing it into a function call called update message. Update message is a function call inside EasyGL that you get at, it's in the application class. So this is now, instead of printing to the terminal, it's going to actually put a message at the bottom of your graphics window, which is going to look nicer. And it's basically just as easy as printing to the terminal. So no reason not to do it. There's only room for like one message, like one string. So it's not as powerful as an entire terminal, but it's very easy to use to get one message to a person at a time. Okay, so let me go and show you what that looks like. Okay, so first I'm just going to run that last one again. So you remember it. So this is the version where first it doesn't highlight right away. Okay, which is kind of annoying. I have to zoom in. So now you saw it appeared there. Again, I have to zoom in before it shows up. And you can see that it's also printing all the information to the terminal. So it's telling me where I clicked. It's telling me the latitude and longitude of that click, and it's telling me the ID of the close intersection. I mean, ID, I should print really the name. ID of the intersection is good for debugging, but not very user-friendly for an end user. I forgot to print the name. And like I say, this works. You can use the terminal as part of your user interface, but it would be nicer if I got it right in the UI. Okay, so I'm going to stop this. And now I'm going to basically just run code that is basically has those two modifications I showed you. So it's not much different. And with those two modifications, let's see, the first thing is, let's see, we're trying to show, what I'm hoping is when I click on an intersection, it highlights right away. Okay, and it does. So whenever I click on an intersection, it highlights right away. But if I zoom in or zoom out, they stay highlighted. Okay, so I've achieved what I wanted. It responds right away, but it's persistent. And it's also now, this is the status bar that I was talking about. I don't know if I can't draw on this, sorry. So let me bring this back up. So you can see if I click on this, it tells me which intersection I selected. So that's a bit more convenient than printing it to the terminal. And let's see, maybe I can go find something. Yeah, so I know the intersection's well around here. This is near where I live. So if I click there, this will be Riverside Drive. Okay, so you can actually check this kind of stuff by going and check around the campus where you actually know the intersections or around your house. Okay, so actually, let me show you one more thing though. Okay, so let me zoom way in. So it's looking pretty good. but you really want to test this pretty carefully. So, okay, so see where my cursor is. Yeah, you guys can see my cursor. So see there's two intersections here very close together. I'm going to click on this one. So you can see where my cursor is. I click on that and I highlight the one next to it. So that seems kind of weird. All right, let's try that again. So go over here. I'm going to click on this one, highlight the one next to it again. Okay. If I click on this one, oh, I got the one next to it. Click on this one. Okay, that time I got it. What's going on? So my selection doesn't seem that accurate. I'm kind of close, but sometimes I'm clicking on, it's clear I'm inside the box for one intersection, but I highlight the one over. What do you think? Yeah. My boxes aren't centered. Yeah, so that's a great idea. If you look carefully at how I drew my boxes, I actually drew them from, the intersection is actually here at the lower left corner, and then I drew them to the right 100 meters and up 100 meters. So I didn't actually center them. So when a person clicked, I found the closest intersection, but that doesn't visually match where I drew the intersection. The person isn't thinking that's the lower left corner of the box, they're thinking that's the middle of the box. So I did things in a bit of a weird way. But this isn't very hard for me to fix. So I'll show you the fix. That. So yeah, my select wasn't accurate. So to fix this is not very hard. What I'm going to do is I'm not going to draw a rectangle from the lower left corner. Well, this lower left corner is at the intersection. I want the center of the box to be where the intersection is. And all I have to do that is I can actually subtract the width over 2 and the height over 2. Lots of different ways I could write that code. I basically made another point, okay, which is basically the width divided by 2 and the height divided by 2, and I subtracted that point from my intersection to get a new lower left corner. And I pass that new lower left corner into my fill rect and say, draw me a box with a certain width and height around that. And this will center it, okay? Like I said, I can write this code in many different ways. There are several different ways you can call fill rect. There's lots of different ways to write this code. Okay, so let me go and demo that just to convince you that it all works. Let's see. Build that, and we'll run it. Okay. Okay, so I'm going to zoom in a bit before I can actually tell what's happening. Okay, so if you see my cursor, it's on a certain intersection, and now that's the one I get. Move over a little, that's the one I get. Go down here. So it's working well. Sometimes they're on top of each other. Now, when I got my intersections, I'm drawing big enough, they're on top of each other. In that case, it's a little unclear, right? It's just whichever one I'm closest to, but it now looks pretty good, right? If I go over here, get that one, haven't seen any mistakes. And there aren't any mistakes, okay? So let's say it bugged me that sometimes my intersection is only partially visible when I highlight it. How could I make it show up so it's always fully visible if it's highlighted? What do you think? Yeah, do you have an idea? Sorry, can you say it again? Draw an intersection, yes. Yeah, so I can basically make 2 passes through my intersection array. I can basically draw everything that's not highlighted, and then I can go back and draw everything that is highlighted. If I did that, because I've drawn it in that order, the highlighted ones are guaranteed to be on top. So you have it's simple to decide what's on top of what with ordering, okay? So you often won't draw things just in one pass. You may make multiple passes because you want to order things properly. I didn't write that version, but if I want to highlight them to be on top, that's what I do. There's one more thing I didn't write, and I'm not going to show this, but how do I not highlight these things? So I've decided that whatever I click on should be highlighted. It does print, information. If I click on this, you'll see the name at the bottom changes. Okay, so it prints information, which I was supposed to do. It highlights it, which I was supposed to do. How do I unhighlight? Like basically, the longer I run this map, the more highlighting I'm going to have. I haven't given any way to unhighlight. Okay, so that's probably a design flaw. doesn't really make sense to say I can highlight things, but I can never stop highlighting. I have to stop running the program. So what would be reasonable things to do then? How can I unhighlight these things? What do you think? Yeah. Okay, so basically the comment is essentially if you have one thing highlighted, right? So when you maybe unhighlight everything and then highlight the thing you clicked on, and that would be reasonable. You just say you're only allowed to highlight one thing. That event, I haven't used it, but if I go back to, let me show you here. If I go back to my mouse, my act on mouse click, there's this event that's passed in that gives me information. I can actually check for things like is shift being held down. So I could do things like if shift's being held down, don't clear the old highlighting. If it is not being held down, clear the old highlighting. That's actually a pretty common convention in programs. So you can still multi-highlight, but you can clear it. I could also have a clear button. You can make a button in the UI that says clear highlighting. And whenever you click that button, it goes through and removes all the highlighting. All of those are reasonable choices, but you should have some way to get rid of the highlighting. You shouldn't say that you keep highlighting more and more. Okay. Okay, so I'm going to quickly show you how, any questions on that? That's how you respond to mouse clicks in your graphics area. Okay, so you probably are going to want to add UI elements. Well, you have to add at least one button. We tell you, well, somehow you should be able to enter the names of intersections essentially with strings, and you can use your M1 function that, given a couple of street names, finds intersections. Now you could do that at the terminal, so that is an option. But even then, you're probably going to want a button to start the process. So you likely are going to want to create additional buttons on the user interface, and it's not that hard to do. So if you want to create a new button that looks just like the buttons I showed you, the ones that EasyGL already has, the procedure is basically 3 steps. You need to have this initial setup callback. So you're basically going to be modifying the UI setup. So you need to now specify that callback. In whatever routine you specify for your initial setup callback, you have to create the button. And when you create the button, you actually you register a callback for that button, saying when this button is clicked, call this function. And you have to write that function. Okay, so what I'm going to do is we're going to basically create an initial setup callback to do this extra setup when the window is first opened. In that initial setup, we're going to create this button. And we're going to tell it that when the button is clicked, it should call a different callback called toggle pink. And that toggle pink is going to change some state. And we're going to have our screen redraw function look at that state to affect how it draws. Okay, so it sounds like a lot of work, but it's not that bad. So first, I got to set up the callbacks. So I told you there were 4 callbacks that you can pass into this application.run. We're now passing in another one. And that's the one to do extra setup that you want. Only called when the window's opened. Whatever name I pass in, I have to write a function that matches that name. It has to have this prototype. And it's very short for this case. I want to create a Pinkify button. So I just say, create button, its name is Pinkify. I want it to be in the 6th row of my user interface, because I counted my buttons, and there are already 0, 1, 2, 3, 4, 5 buttons above it that I want. So I want all the zoom and arrow buttons above it. So I want it to be in the 6th position, and I have to say what its callback function is. When it's clicked, what do you do? Whatever function name I put there, I have to write that one. I said it's going to be called toggle pink. I can call it anything I want, but it has to take this function signature. It has to take the EasyGL application pointer, and it takes a GTK widget pointer. I'm not using the GTK widget pointer right now, and you might not use it at all. That's pretty common. So all I do is I have a global variable called Pinkify, and I just invert it. So if Pinkify was on, when you click this, I turn it off. If Pinkify was off, when you click this, I turn it on. And then I refresh my draw. because the same reason that I had in the mouse, act on mouse move, I want the update to take place right away. Okay, so the last thing I need, well, I basically have made this global variable. I have these callbacks communicating. They're going to communicate again through a global variable. So I have this pinkified variable that says, do I draw a pink background or not? And the last thing I need to do is I change my redraw function. So my redraw function now has a little bit more code. I just check this pinkified global variable. And if it's set, I basically want to draw a pink background. That's what my button is doing. To figure out how I want to fill the whole drawing area. So what I can do is I can say, get the visible world. That basically gives me the lower left and the upper right coordinates, in world coordinates of what's visible on the screen in my drawing canvas. I get that and I just store it in an EasyGL rectangle. This color is pink. Okay, so I set a nice pink color. And then I say fill in that rectangle. And I do that first, and then afterwards I do all my regular drawing. Whoops. I do all my regular drawing of intersections and so on. Why do I do it first? Because it matters. Can I do it last? Is it important that I draw this big pink rectangle first? What do you think? It's not a hard question. So, what would happen if I drew it last? Yeah, this is a super pinkify button, right? Turns the whole screen pink. So I want to draw it first because I want it to be my background. But this is an easy way to get a background. Okay, so let me quickly demo that. And let's see. Okay, so let me exit out of this. And build this. Run it. Okay. So it looks like it did before, except you see I've now got this new pinkify button. I said I wanted it to be in the 5th row. So this is row 0, row 1, row 2, row 3, row 4, row 5. Well, it's after the 5th row. But I said, actually, I said I wanted the 6th row. So it's in the 6th row. Okay, there are 5 things. Well, it starts at 0, 0 through 5 are above it. Okay, so that's where I decided I want to put it. If I click pinkify, I get a pink background, right? No matter how much I zoom in or zoom out, my background's still pink because I'm using get visible world to get the whole area on the screen. If I click on pinkify again, whoops, clicked on the wrong thing. Let me try that again. I clicked on proceed, which closes the graphics window. All right, I click on it again, right? Turns on and off. My TA is going to be super impressed, right? Remembers whether I have it on or off. Okay, so it works. Okay, so it's a pretty simple button, but basically it's not very hard to make buttons that do things. You just follow the recipe that I showed you. Any questions on any of that? Okay, and for those who are still, I'm going to show you one more demo. So basically what I'm going to do is for people who just arrived for the second tutorial, you're going to see the last thing first. We'll just do a modulo tutorial. And I'm kind of going in gradually increasing, well, all the things I showed you so far, you're probably going to wind up doing. Okay, this next thing you don't have to do. Okay, so, and let me see if I make the font bigger. Let's see. Okay, hopefully you guys can see that okay. Okay, so I'm in the libstreetmap resources directory. Okay, libstreetmap resources is where you can put things that are not source code. They're like images, if you want to have bitmapped images that you draw, and this main.ui file. The main.ui file, you can actually read it, it's human readable. It's an XML file that actually describes the window layout. So you can actually edit this by hand if you wanted, but it's kind of inconvenient. I don't really want to edit this by hand. So there is an editor called Glade on the UG machine. So I type glade main.ui, and it basically brings up my UI. And it's kind of small, so I'm going to make this bigger. And it's basically a hierarchical view. We've created this for you, okay, but you can change it. So if you don't like the UI layout, you can change it. You can do anything you want, right? You can add stuff, delete stuff, reorder the buttons. So there's a little bit of information about this in the EasyGL handout. And this is kind of like optional above and beyond. I'm going to show you one thing you should do. So this is like part of your reward for coming to this tutorial. It's on the rubric, so you should change this. If I go back to, let me go back to my application here. So let me run the EasyGL application. Oops. Okay, let me run this again. All right, so I'm going to run my last one of these EasyGL applications. What's the name of the program? You can read it on the title bar. So what do you think? This EasyGL example program, is that a good name for your team's program? No, it's not a good name for your team's program. So we're going to change it. So how are we going to change it? We're in Glade. Main window is basically, you see I clicked on main window and the whole thing's highlighted in green. So that's basically my whole graph, the whole application. If I click on outer grid, it basically highlights a certain part. If I click on inner grid, that's actually what made all these buttons on the right-hand side. So there's various things in here. If I click on main window, I go down here, I click on general, and it gives me some information about this main window. And you can see there's this name, EasyGL application example. If I turn off this checkbox, I can edit it. So now I'm going to change that to 297 Super Mapper. Marks. Okay, should probably be more subtle, right? You want marks, but don't actually tell the TA, just strongly imply it, okay? But I'm just going to flat out say, give me marks. So I save this, okay? And now I'm going to run my program again. Okay, and now you see like the name of this program has been changed. Okay, your TA is going to literally check off on a rubric that you chose a name. You can come up with a cool name if you want. You can do lots more with Glade. So you can create additional user interface elements if you want. You can, let's see, another easy thing to do would be, let's say I take this. Let's say I decide this zoom fit button is so important that I want to move it up. Okay, I could go here and I could basically say, right now it's essentially in row 5. I could say I want to have it in like row 3, for example. Okay, and then I need to go find what was in row 3 and move it. And I'm not going to do that just in the interest of time. But basically I can move around the user interface elements. I can create new ones. If I create new ones, you have to follow the EasyGL handout and the GTK documentation to see how to hook them up. It is optional to create any new things or to ever, well, you should change the name of the program. Okay, so go change the name of the program. It'll take you 2 minutes after this. But anything else in Glade or GTK, you don't have to do. It'll be considered an extra feature if you do. Okay, so you can do it, but if you're like, I'm busy, I don't want to learn GTK, that's totally fine. Okay, that's all I had to say for the tutorial today. And let's see, let's get out of here. So thanks everybody, and it'll give like 1 minute for people to get settled who came in for the new tutorial, and then we'll start the other part of that modulo tutorial. Yeah, do you have a question?
Are we still getting tests
Load map does have a performance test. It's the same as M1. Okay, so as long as you don't get slower, you're fine. We actually, in milestone 2, don't even really pay much attention to that one. It's just there so you can see it. But your TA is actually going to grade you. Yeah, does that make sense? One last thing that I'll point out. How many people did, so before you leave, how many people did EC 297 and knit like more than 6 days ago? Okay, so a few. We haven't, my fault, we had a slightly outdated version of EasyGL. It's not much different, but there are a couple of missing features in the version. I'll post something on Piazza that's just which files do you just download to update it. Okay? It doesn't change how it works at all. It's just there are a couple of annoying things that students have hit, which we actually have already fixed. And I didn't actually put in until until 6 days ago. So if you're hitting an annoying, like disabled graphics error, it's not your fault. It's basically because you grabbed the code before we fixed that one. So I'll put something on Piazza. Yeah. Yeah. This is the redraw function. Okay, so this will be called by EasyGL. So application.run does not come back for a long time. Okay, it doesn't come back till you hit proceed. So in that application.run function, as part of EasyGL, whenever it needs a redraw, it's going to call this. And the reason it's going to call this is because I told it to. Go back and screen. Actually, I didn't show it. It's in the top. There's another line above here which basically says what is my redraw function for the canvas. So I didn't show it.
Well, we're right here.
You write that function, and it doesn't have to. Yeah, there's like a line called. I can show it to you here. It's let's see. It's basically the same as. Whoops. Yeah, let me go back up. Yeah, it's right here. Okay. So. Actually, I'm just going to stop recording. So, just 1 second here.